Hi everyone, this is Miss Hsieh. This is the third part of our Stoichiometry series, and in this lesson we are going to learn how to do mass-to-mass stoichiometry problems. First, let's review the 5 steps for solving stoichiometry problems. Step 1, identify the given and the unknown. Step 2, write a balanced chemical equation. Step 3, convert the given to moles. We will skip this step if the given is already in moles. Step 4, convert the moles of the given to moles of the unknown using the mole ratio. And step 5, convert the moles of the unknown to the wanted unit. And we will skip this step if the wanted unit is in moles. Now, since we are doing mass-to-mass stoichiometry problems, that means we are converting from grams of the given to grams of the unknown. So all 5 steps will be used. None of these steps will be skipped. Let's do a few examples. Number 1, how many grams of magnesium oxide are formed when 20 grams of magnesium react with oxygen according to the following balanced equation? 2 Mg plus O2 yields 2 MgO. We'll do this following the 5 steps. So the first step is to identify the given and unknown. So the given in this problem is 20 grams of magnesium, and the unknown is the grams of magnesium oxide. And our first step is done. Second step, write a balanced chemical equation. We are provided a chemical equation and it is already balanced, so second step is done. Step 3, convert the given to moles. Our given is 20 grams of magnesium, so we will write that out and we will start the dimensional analysis grid like this. Now we need to convert from grams to moles, so I need the GFM of magnesium. And the GFM of magnesium from the periodic table is 24.305. And we will put 24.305 grams of magnesium on the bottom and 1 mole of magnesium on the top. And we will do this because grams of magnesium need to be canceled out. And that is step 3 finished. Check it off. Step 4, convert the moles of the given to moles of the unknown using the mole ratio. Okay, the mole ratio comes from the coefficients in the balanced equation. Let's look at the given first. We got 2 moles of magnesium, and we'll put that on the bottom because I want to cancel out that given, the magnesium. And now I want to get to the unknown, and the unknown is magnesium oxide. So that would be 2 moles of magnesium oxide on the top. Moles of magnesium cancel out, and our step 4 is finished. And the last step is to convert the moles of the unknown to the wanted unit. The wanted unit is grams. So we need the GFM for MgO. And I'm going to look this up on the periodic table. Mg, we already know, has a mass of 24.305, and oxygen has a mass of 15.999, and we're going to add those up, and I get 40.304. So what this means is 40.304 grams of magnesium oxide is in 1 mole of magnesium oxide, and we will put that in the grid. I will put 1 mole MgO on the bottom and 40.304 grams MgO on the top. And moles of MgO will then cancel, and step 5 is finished. So this is the work. Now, we can also cancel the 2's in the mole ratio here because they are the same on the top and the bottom. So now in the calculator, what we need to do is multiply all the numbers on the top and divide by all the numbers on the bottom, and we can ignore ones. So we will do 20 times 40.304 and divide by 24.305. And the answer, according to the calculator, is 33.165, and it keeps going. But if we look back at our given, there is one sig fig. The reason why there's one sig fig is because the 0 at the end of a number without a decimal is not significant. So there's only one sig fig. So I'm going to round this to one sig fig. And the answer is 30 grams MgO. Number 2, what mass of water would be required to react completely with 30 grams of sodium according to the balanced equation? 2H2O plus 2Na yields H2 plus 2NaOH. The first step is to identify the given and unknown. The given is 30 grams of sodium, and the unknown is mass of water. Remember that mass is measured in grams, so what we are looking for is grams of water. And we are done with the first step. The second step is to write a balanced chemical equation. Well, we are provided with that balanced equation, so step 2 is finished. Step 3, convert the given to moles. The given is 30 grams of sodium, Na. And we are going to convert from grams to moles, so I need the GFM for Na. And the GFM for Na is 22.990, and we will put that on the bottom, 22.990 grams Na, and we'll put 1 mole Na on the top. The grams of Na will cancel out, and step 3 is done. Step 4, convert the moles of the given to the moles of the unknown using the mole ratio. So the mole ratio again comes from the balanced equation. They're the coefficients. So 2 moles of Na, we'll put that on the bottom because that is what we want to cancel out. And we are looking for water. So 2 moles of water on the top. Oops, that's me. Change the ink color. So 2 moles of water, H2O, on the top. Okay, so step 4 is finished. Step 5, convert moles of the unknown to the wanted unit. Well, our wanted unit is grams, so I'm going to need the GFM for water. We got 2 H's, and H has a mass of 1.008, and O got one of it, and it's got a mass of 15.999, and when we add that up, that would be 18.015. So again, this means that there's 18.015 grams in 1 mole of water. All right, and so we'll put 1 mole of water on the bottom and 18.015 grams of water on the top. The moles of water will cancel out, and also the 2's will cancel out in the mole ratio. Now in the calculator, we will multiply all the numbers on the top and divide by all the numbers on the bottom, ignoring the ones. So 30 times 18.015 divided by 22.990. And this time we have 2 sig figs. Notice that this is different from the last question that we just did. There is a decimal after the 0 at the end. So that means that 0 is actually significant this time. So there will be 2 sig figs, and we will therefore round our answer to 2 sig figs. And the answer is 24 grams of water. And one last example. Calculate the mass of water produced as 3.00 grams of carbon dioxide are generated from the combustion of methane. CH4 plus 2O2 yields CO2 plus 2H2O. Again, we'll follow the 5 steps. So the first step is to identify the given and unknown. The given is 3 grams of carbon dioxide, and the unknown is the mass of water. So that means grams of water. And our first step is finished. The second step is to write a balanced chemical equation, and we are provided with the balanced equation. So step 2 is also finished. Step 3, convert the given to moles. Our given is 3.00 grams of carbon dioxide, CO2, and we need to convert this to moles, and so we need the GFM for CO2. Well, C, there's one C, and its mass is 12.011, and there are two O's, and O's mass is 15.999. And we will add those up, and we get 44.009. So 44.009 grams of CO2 equals 1 mole of CO2. So 44.009 grams of CO2 will go on the bottom and 1 mole CO2 on the top. This will allow us to cancel grams of CO2, and we are finished with the third step. The fourth step is to convert the moles of the given to moles of the unknown using the mole ratio. Well, let's start with the given. We got 1 mole of CO2. Since there's no coefficient, that means the coefficient is 1. And we are looking for water, and we have 2 moles of water. So 2 moles H2O on the top. And step 4 is finished. Step 5, convert moles of the unknown to the wanted unit. Well, our wanted unit is grams, and that means I need the GFM for water. Now, we just calculated that on number 2, so I'm not going to calculate that again. The GFM for water is 18.015, and so we'll put 1 mole water on the bottom and 18.015 grams of water on the top. Moles of H2O will cancel out, and I forgot to cancel out moles of CO2 here, so let's do that also. And step 5 is done. So this time we have no numbers that will cancel out each other, so all the numbers will be put into the calculator other than the ones. So remember, again, multiply all the numbers on the top and divide by all the numbers on the bottom. So we'll take 3.00 times 2 times 18.015 and divide 44.009. We have 3 sig figs in the given, so we'll have 3 sig figs in the answer, and the answer is 2.46 grams of water. All right, so this is how you do grams to grams or mass to mass stoichiometry problems. These are the most common type of stoichiometry problems, and I hope that this video has helped you.